Good evening, students. Today we will discuss about memory representation of a 2D array. I hope the fundamental video related to the 2D array already you have seen in the last post. So today we will discuss how a 2D array is represented in the memory. So memory representation of a 2D array is possible in two different ways. One is row measure wise and the second is column measure wise. As you know, every variable has a memory location and array is a continuous memory allocation. So when we declare any array, either 1D array or 2D array, it occupies some memory space and every block contains some address. So how the address is allotted in the memory, we will discuss with the help of this. Suppose if I declare a 2D array, 1 INTA square bracket new INT 3 by 4. It means the array contains 3 rows and 4 columns. So the general representation of this array will be like this way. If the memory is allocated in row measure wise, and suppose if the, as you know, first let us discuss about index concept. If the array is of 3 by 4 size, the row number 0, row number 1, row number 2, this is column number 0, column number 1, column number 2, column number 3. These all are rows and this is the column. This basic fundamentals already we have discussed in a previous video. So this is row and column. Every block has a unique address. Suppose if the address of first block is 1000, okay, and if memory is allocated in row measure wise, because one INT occupies 4 bytes in memory, so the next block address will be 1004, this will be 1008, this will be 1012, 1016, 1020, 1024, 1028, 1032, 1036, 1040 and 1044. So this allotment is for row measure wise. Suppose if same array is allocated in column measure wise, so how the memory will be allotted? In column measure wise, suppose if the base address, the beginning address is 1000, so the 1004 will be for this block, 1008 will be for this block, 1012 for this, 1016, 1020, 1024, 1028, 1032, 1036, 1040, 1041. So you can see either the memory is allocated in row measure wise or column measure wise, the address for the first block and the address of the last block will remain same. Either it is row measure wise or column measure wise. When it is row measure wise, then also if first block is 1000, so in column also it will be 1000. Last is 1044, so here also last will be 1044. But remaining blocks address will be different. So we have a formula to calculate the address of a particular block. Okay. If you want to calculate address of any particular block using row measure wise, suppose if you want to calculate the address of Aij, A row, A column, I number row and J number column. So we have a formula: base address plus space I minus LR into C plus J minus LC. This is the formula. What is the terms? I and J is the row and column for which you are determining, for which you are going to find. BA is the base address. Generally the first address is known as base address, but in some cases other than first address, some other address may be given in the question in between any block. So in that time we can consider base address, that space one location, how much space is needed, that S. LR, if the base address is given for the very first location, in that case LR and LC will be 0, 0. But sometime when address is not given for the first location, if it is given for some other location, suppose if it is given for 1, 1, So that time LR will be 1 and LC will be 1. If base address we consider 1020, so LR will be 1 and LC will be 1. If base address is 1000, so LR LCA. If base address is 1028, so LR will be 1, LC will be 3. So C is the total number of column. In row measure wise, we multiply by column. Nowhere row will be used. Okay, in the formula. Column measure wise, the formula is almost same. If column measure wise you want to find the address of a base address plus space I minus LR, no multiplication here, J minus LC, and in this you will multiply by row. So in row measure wise formula, you can see here we multiply by column, and in column measure wise formula we multiply by row. Okay. So now with the help of some question, we will understand it, how to solve it. So now we discuss with the help of two different questions. You can see the first question, a matrix A 15 by 10 is stored with each element requiring 8 bytes of storage. If the base address is 1400, determine the address at 8, 10, 7 when the matrix is stored in row measure wise. So firstly we will write the formula for row measure wise, and we have to determine the address of 10, 7. So we will write like this way, address of 10, 7 is equal to base address plus space I minus LR multiplied by column plus J minus LC. Base address is 1400, just put the value. Space is given 8 bytes, 8, I, 10 and J 7. So 10 minus. Now you can see here only base address word is given. So we will consider LR and LC as 0, 0. So 10 minus 0 multiplied by column. The matrix size is given 15 by 10. That means 15 is a row, 10 is a column. So 10 plus J value is 7 minus LC. Again LC is 0 because only base address is given. So just we have to simplify this formula. 1400 plus 8, 10 minus 0 is 10 into 10, that is 100, plus 7 minus 0 is 7, 107. Now 107 into 8, 1400 plus 8 into 107, 1400 plus this will be 856, and the final answer is 2256. So the address for 8, 10, 7 in row measure order, row measure wise will be 2256. So this way we can solve row measure wise. Now let us see one question based on column measure wise. Here some question is in different way. A matrix A m by n is stored with each element requiring 4 bytes of storage. If the address at A11 is 1500 and the address at A45 is 1608, means two different addresses are given. Base address word is not given. Okay. Determine the number of rows of the matrix when it is stored in column measure wise. This time we have to find the number of rows. Rows is unknown and two different addresses are given. So in this way, any one address we can consider as a base address, and one you can consider just you are going to find. So suppose if you are going to find the address of A45. So if you are finding address of A45, so formula in column measure wise is base address plus space I minus LR. You will not multiply anything. J minus LC multiplied by row. Now you can see 45 address of 45 is already given 1608. So in left side you can write 1608. Now base address we can consider this 1500. If we are considering 1500 as a base address, so LR and LC will be 1 and 1. Now space is given here 4 bytes. So 4 I will be 4 minus LR is 1 plus J is this 5 minus LC will be also 1, and number of row, that is only unknown. We have to find the number of row. So if this equation, in any equation if one value is unknown, we can find. So firstly we can transfer this value this side. So 1608 minus 1500 is equal to 4. Then 4 minus 1 is 3 plus 5 minus 1 4r. This is 108 is equal to 4 into 3 plus 4r. Now as you know, this we can write 108 by 4. This will come this side is equal to 3 plus 4r. Okay. If we will simplify it, 108 divided by 4, 27 is equal to 3 plus 4r. Again 3 you will transfer this side. 24 is equal to 4r. That's why r is equal to 24 by 4. That means 6. So number of rows for this matrix is 6. So this way, on the basis of this formula, we can get different question, some variation. Okay, is there in the question. So any variation is there. If you know the formula, if you identify each and every term, like what is the space, what is the ij value, what is the LRLC, so easily we can find. So I hope this topic is clear. Thank you.